In today's video we will be looking at what happens when you have multiple DC shorts in a system where the DC power supply is using a floating ground. So what does a floating ground mean when you are trying to troubleshoot a fault? This is where it gets tricky. Because the floating ground is not tied to earth ground, but rather simply a reference point, provided by the PLC itself through the DCS and the COM connection on each module. A short to ground will not generally short out the circuit and blow a fuse. In fact, if you have only one DC short to ground, you are not likely to notice it at all. Let's take a look at the schematic diagram for the circuit. Now, in conjunction with the ladder diagram, have a look at the circuit working correctly with no shorts. With S1 in the on position, pressing PB1 will light and seal in L1. Pressing PB2 will light and seal in L2. And pressing PB3 will light and seal in L3. Switching S1 to off and then back on will reset the circuit. So now we'll add a short. Let's take the wire at L1-1 and short it to ground. First we will lock out tagout and then we will verify the short. The wire from L1-1 goes through terminal block TB1-8 on its way to COM1. You can verify this by looking at the CWD. Disconnect the wire at both ends, L1-1 and TB1-8. Measure from either end of the disconnected wire to ground. If it measures 0 ohms, we have a short to ground. So this wire definitely has a short to ground. Let's connect both ends again, leaving it shorted. Remove the lock and restore power to the system. Now try the circuit again. It is still working fine because nothing is bypassing the path to the light. Without a connection between G and D in the output, nothing will change. But what would happen if there was another short to ground in the circuit? Lock out tagout again and we will create a short from L3-1 to ground. Let's verify L3-1 is shorted to ground. Disconnect the wire at L3-1 and measure from L3-1 to ground. 0 ohms, so we now have a short at PB3-1 as well as the short we previously created at the TB1-8 to L3-1 wire. Let's see what happens now. Remove the lock. Restore power to the circuit. With S1 in the on position, press PB1. What happens? L1 and L3 have both lit up. Reset the circuit and press PB2. Good, only L2 lights up. Reset the circuit again and press PB3. L3 lights up, but so does L1. The dual shorts to ground created a common connection. Pressing PB1 sends a signal not only to L1 but also to L3. And pressing PB3 sends a signal not only to L3 but also to L1. Reset the circuit again. The PLC output module provides a strong clue here that we are dealing with a short outside of the PLC signal. Press PB1 again. but this time pay attention to the lights on the PLC output module. Notice that although both L1 and L3 are lit, the output module is only sending a signal to L1 at 0200. Reset the circuit and press PB2. Good, only L2 lights up, and the PLC is only sending a signal to L2 via 0201. Reset the circuit again and press PB3. And now notice that although L1 and L3 are both lit, the PLC is only sending a signal to L3 via 0202. Lockout tagout again and replace the wire from L1-1 to TB1-8. As well as L3. Remove the lock. Restore power to the circuit. Test to confirm that the fault has been solved. As you can see, it is working correctly, now that we have successfully solved both DC shorts. Remember, if you have a weird issue with your DC circuit where activating one component also affects another unrelated component, and you are using a circuit with a floating ground, you are looking for at least 2 shorts to ground. You will need to identify and fix both before you have solved a fault successfully. Make sure you identify both before fixing either of them. Once you have solved one, the issue effectively disappears and it is much harder to see where the other short is located.